just find dy dx. But the fact that they've said that it's going to have to be in terms of, and that's what they mean, they're not saying it's got to be in terms of x and y, it's going to have to be anyway.
Yeah.
In other words, it can't just be in terms of x.
So rearrange it to get x and y on each side and then differentiate.
Oh, right. Yes. I mean, that would be one way of tackling it. We could say, okay, how can we possibly get dy dx if we don't know what y is?
Yeah.
In terms of x. So we could say, for part A, let's try it that way and see what happens. It might be possible, you see. And in which case, we will be slightly ignoring their instructions. I'm sorry for being rude. Eating.
No, that's fine.
It's all gone now. Right. Oh, by the way, sorry, I have to just do this.
So could we say y cubed equals 2 minus x squared for a first step?
Yes. Y cubed equals 2x squared. Good. And then?
2 minus x squared.
I stand corrected. Did I say 2x squared? That is so bad. Sorry, I'm doing something else. That's my excuse.
Mm.
But yeah, good. I'm glad you're awake. If I'm not, right. So, so y cubed equals 2 minus x squared, and therefore y equals
the cube root of 2 minus x squared.
Which we could write as 2 minus x squared all to the power of?
Minus 3.
Ouch.
Oh no, a third.
Thank you. And then we could find dy dx by using the chain rule. And that would be what?
So we'd say this is the same as 1 over 2 minus x squared to the minus 3. No, wait. No. Okay, what we do is we just say, okay, we say a third 2 minus x squared.
Yes.
To a minus 2/3.
Good.
Times 2x.
Careful.
Minus 2x.
Minus 2x. Yeah, good. And then we could simplify it by all means. Minus 2/3 x of the same thing, yeah?
Yep.
All right. But now we've got an explicit, what's called an explicit function of dy dx, explicit meaning explicitly in terms of x. Now what they've said here is don't bother doing that. They're not denying that you could, I don't think. That they'll be aware, obviously, that we could do what we just did.
Yeah.
But they are saying don't bother. Notice that we've got an explicit function of dy dx in terms of x, explicitly in terms of x. But they're saying, oh, just leave it implicitly in terms of x. In other words, get it in terms of x and y, where y, well, it probably is a function of x, but don't bother finding out this function of x, which is equal to y, which is what y is, this function of x here. Don't bother finding that out. Go straight from here, where we, what y is as a function of x is left implicit. Go straight from there to finding out what dy dx is, and don't even bother making that explicit before or after the differentiation. Do what's called implicit differentiation on that, okay?
Right. Okay.
Now notice how I'm writing it. And let's differentiate term by term. After all, you know, if y equals this stuff plus that stuff minus that stuff, you would just say dy dx equals the derivative of that plus the derivative of that minus the derivative of that, wouldn't you?
Yeah. Yeah.
And we can do the same even if y isn't the subject. You know, the derivative of that plus the derivative of that is going to be equal to the derivative of 2. Okay?
But you don't want to do that.
Yes, we do. We're going to do it this way. That's what they've told us to do. They've said find an expression in terms of x and y. Well, it will be if we don't bother to make y the subject of this expression. If we leave y as an implicit function of x, we just say, oh, well, it's some function of x, or we don't know what. Then we will be able to see what dy dx is soon enough. We'll be able to make dy dx the subject, but it won't be explicitly in terms of x. It will be in terms of x and y. And we won't bother finding out what y means as a function of x, which is this. This is what y means, isn't it?
Yeah. Yeah.
Right?
Yeah.
So the choice, you know, which they're deflecting us one way here, in this case, we've got a choice, but very often it helps, you know, making y an explicit function of x isn't an option, which is why you need to know how to differentiate implicitly as well.
Okay.
So differentiating implicitly, what have we got? What are we doing? We're differentiating everything with respect to x.
So, well, you'd get 2x.
Good. That's that one done. Now, what's the derivative with respect to x of y cubed? Well, y is like a u in the chain rule formula, isn't it? Where the derivative of the whole function is the derivative with respect to the inner function, which we usually call u, multiplied by the derivative of the inner function with respect to x. Yeah? That's what we've been doing a lot of, differentiating a function of an inner function, yeah?
Yeah.
So what do we get?
So 3y squared.
Yes. So that's that, isn't it?
Yeah.
Yeah.
And then times y, or
times, what's du dx going to be? What's the derivative of the inner function?
1.
With respect to y, yes. But notice we're differentiating everything with respect to x. So that's why we're applying the chain rule.
Okay, so times x. So times, well, I don't know.
y is an implicit function of x, don't forget.
Oh, yes, okay.
Whatever it is.
So y equals 2 minus x squared all to the third.
I don't think so. All we're saying is we're multiplying by the derivative of y.
Yeah, isn't that 1?
With respect to y, yes, but with respect to x, what do we call the derivative of y with respect to x?
I don't know.
Here's y
Mm.
with respect to x, you know, as a function of x. The derivative of that we call,
dy by dx.
well, it doesn't matter what we call it, but the point is that's what we've got here, isn't it? The derivative of y with respect to x. Now that's du dx, confusingly.
Mm.
Then that just goes to show, you know, that's a point against u, isn't it? That's a point against the formula and in favor of looking at this as a chain rule. In other words, applying the correct rule to a composite function. We've got blob cubed is 3 blob squared,
Yeah.
and then multiplied by the derivative of the inner function, which is dy dx.
So what is dy by dx?
We don't know.
Oh.
Although
Right.
in a minute we'll be able to give a good expression for it, won't we? What about this one? What's the derivative of 2 with respect to x?
0.
Right. Ah, but look, you know, we had to sort of be cool about, you know, back off from saying what dy dx is.
Mm.
But now we can make dy dx the subject of this equation, can't we?
Well, we could say minus 2x
Yes,
over 3y squared equals dy by dx.
exactly. To put it the other way around. So that this is the subject, dy dx equals what you just said.
Minus 2x over 3y squared.
So we've got a different result doing it this way.
Yeah.
Earlier on, we got dy dx equals minus 2/3 x of all that stuff.
Yeah.
Now we've got something looking very different. Although, by the way, can make it look a bit more similar, couldn't we, by saying it's minus 2/3 of stuff? Or even, to make it look similar, more similar to the way we wrote it, minus 2/3 x times 1 over y squared, sorry. Earlier on, we had minus 2/3 x times that stuff.
Yeah.
Now we've got minus 2/3 x times that stuff.
Yeah.
But then if we took the trouble to make y the subject, which is that, so what's the square of that?
What's the square of that?
See why I'm asking you that? Because we want the square of y on the bottom here.
Right.
All right, hang on. Let's write it as y to the minus 2. Even better. So what's this, which is y to the power of minus 2? What would we have?
What's all of that to the power of minus 2? That would be 1 over
It would be 1 over the square of that, which would be what?
which would be 1 over all of that to a half.
Are you squaring or square rooting?
If you squared that, it would be to a half, wouldn't it?
What's x to the third all squared?
Is that? I thought it would be the square root of x.
No. I mean, x to the third means what?
Means cube root.
Yes.
So
Now,
the
if we
cube.
square a cubed root, we don't get a square root, no. Expand it. Think about what happens if you expand this. Remove the brackets, and what have you got?
Can't you just? Isn't it just x to the 2/3?
Yes, that's better. So this squared is
2 minus x squared to the 2/3.
yes. And if it's 1 over that, we could put a negative in the index like that.
Yeah.
So notice that what we got before is, when we bother to get y as an explicit function of x, what we've got here is exactly the same as we had earlier when we did it explicitly. All right,
Yes.
but they're saying, show us that you can do it implicitly and just have that.
Okay.
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 Let's try it again. X squared plus 5y squared equals 14. X squared.
So how come we got different answers in the end for the?
Sorry,
How come we got different answers in the end?
we didn't.
Oh, we didn't.
We
Okay.
just showed, didn't we, that that's minus 2/3 x. The point is, they've asked for it in this form in terms of x and y. If we're able to, we're not always, but in this case, we're able to remove the y and put it in terms of x, then we just get what we had before.
Okay. Okay, I understand now. Okay.
Where that was 2 minus x squared to the power of minus 2/3. Where we're just substituting 2 minus x squared all to the power of a third for y.
Right.
All right, so be aware that you may or may not be able to do it explicitly if you're doing implicit differentiation, but whenever you see the chance to differentiate implicitly, do it like that, yeah. It's just convenient. So x squared plus 5y squared equals 14.
So
Term
you
by
get
term?
2x plus 10y times dy by dx
Yes.
equals 0.
Giving
minus 2x. Huh?
what is? When I said giving, I meant giving what sentence?
Oh.
Not just, no, I'm being pedantic in a way. I mean, you're quite rightly telling me one side of the equation. I want the whole equation. Because I think it's important to be aware what you're giving here. You're giving an expression for?
For I don't know.
Well, I interrupted. Say what you were going to say, and then I'll tell you the very.
I was going to make it equal to dy by dx.
What, exactly. Sorry. So what am I writing?
Dy by dx equals.
Thank you. That's what I wanted. That's all I wanted. An announcement of the quantity you're giving.
Minus 2x over 10y.
In other words,
minus x over 5y.
good. Done. Because it's in, the simplest form of an expression in x and y. Yeah?
Yeah.
This one. Okay, go ahead.
2x plus 6 minus 8 plus 10.
Don't forget we're differentiating every term with respect to what variable.
So 8 times dy by dx.
Yes, and that, you know, and then having done that methodically, then you remember, well, of course I know that when I'm going from y to dy dx, if I've got 3 of them, I'll have 3 of that one.
Okay. And then 10y dy by dx.
So minus 8 dy dx, and then plus 10y dy dx, absolutely. Equals?
0.
Lovely.
And
And
then suppose, what would you do?
well, what did they want?
Dy by dx.
Yeah.
So get the dy by dx's on one side.
Good. Yeah.
So
Let's leave them on the left then.
okay. So minus 8 dy by dx.
I'm going to put the positive term first, if you don't mind.
Yeah, that's fine. Minus 2
Equals?
minus 2x minus 6.
Yes, it is minus both of them. Well spotted. I was confused there.
Then you could say so you could say 2 and then bracket 5y dy by dx
Yeah, you could.
minus.
Should we bring more out?
Oh yeah, the dy by dx as well.
Yeah, exactly. To do and yeah. 2 dy dx, and then inside
5y minus 4.
Yeah.
Then say 2 dy by dx equals minus 2x minus 6 over 5y minus 4.
Right.
And then dy by dx equals all of that over 2.
Yeah, which simplifies to what?
Which simplifies to you can just put minus 2x minus 6 over 10y minus 8.
Yeah, you could, but isn't that, I mean, that's fine. It's not a step backwards exactly, because then you would see, oh, surely I can.
Well, yeah, you
more
could
simplifying,
simplify it further from there. Yeah, you could say.
But wouldn't it be easier to simplify straight away by saying, okay, if I'm halving the whole of a fraction, I could, in effect, what you're suggesting is double the denominator, but better than doubling the denominator would be perhaps quicker and easier would be. What would have the same effect as doubling the denominator?
Halving the numerator.
Exactly. Giving
x minus 3 over 5y.
minus x minus 3, yeah. And then can we get rid of those minus signs? Some of them? I think we could write x plus 3 over. So what liberty have I taken with the numerator?
Yeah. I don't know, minus 5y plus 4.
Or even more simply,
4 minus 5y.
yeah. Using that useful trick of saying, you know, the negative of a difference is just switching them around, isn't it?
Yeah. Okay.
Because we've taken the negative of the top,
Yeah.
so negative of the bottom, and then that's the simplest of all.
Good.
Unless we were to make, find out what y is as a function of x and make it an explicit, we would call it derivative. But implicit, that's what they wanted. Let's do this, because it is a bit different. But then this is what happens in a book, you see. There's never any excuse to stop. Damn. Right. So, oh, damn. Right. I think I'm going to space these out a bit so that we're sure we can see what's going on.
Okay.
And I'm even going to do this. And I hope it'll help. Oh, I didn't need to do that, did I? Duh. Oh. Minus 4x equals 0. Okay.
Okay.
Here's where I needed to do it. That happened earlier, didn't it?
What's that?
The first term.
So that'll be 3y squared times dy by dx.
Yes.
Plus okay, so for this we've got to use quotient rule. Is that right?
Is this a quotient?
I know what we've got to do. I don't know what the correct name of the rule we're using is.
Okay, well, let's clarify that. A product means what?
A product. The product rule.
Yeah, but what's a product?
A result.
No,
No,
it's more specific.
Multiplying?
Yes, the result of multiplying.
Yeah.
Or just a multiplication if you don't seem to have the result there.
Yeah. So, well, to do this one, we say it was 6 x
Yeah.
times y.
Yeah.
6
Good.
plus 3x squared, just 3x squared.
What you're forgetting is we're differentiating with respect to
dy by dx.
With respect to x, and therefore y is differentiating to dy dx. Yeah.
Okay.
Well, that part of it, and that part of it, and then the other bits are left alone.
And that first y, we don't need a dy by dx for that one.
No, because we're not differentiating it. We're leaving it alone, aren't we, in the product rule?
Okay.
So you were quite right to say 6x times just y left alone. We're differentiating the 3x squared, but not the y.
And then minus 4x
Ouch.
will just become -4.
Yeah, with respect to x, yes.
Yeah.
I mean, if it was with respect to something further inside, like z, then it would be 4 dx dz. But perhaps that's not helping. We'll say that. And equals.
Oh, I just lost you. Hold on. Equals 0.
Yeah. Next.
Then we could. So. Okay. Well, what I'd probably do is take all the things about dy by dx to the other side.
Right. Why the other though? When if we're trying to make dy dx the subject on the left-hand side, and they're already on the left-hand side, why not leave them there?
I didn't really think it made a difference.
No, true. Okay, I'm only expressing a mild preference. I just don't see an argument against it. If they're on the left-hand side.
I'll leave the dy by the x's on the left-hand side.
Yes, please.
Yeah, and take the other side.
I'm just slightly worried if you want to do the opposite, because I don't see any reason at all.
So, no, then you'd get 4 minus 6xy on the other side.
Indeed, yes. Oh, so I should be writing this. I see what you mean, yes. That's fine.
And then you could say on the left-hand side, we've got how do we do this?
Where are we trying to get to?
We're trying to get to just dy by dx.
Yes, on the left.
So we'd
something similar happened last time, didn't it?
Yeah, well, I'm just thinking how we'd factorize it. So, I mean, we take out 3 dy dx.
Yeah.
Times y squared plus x squared equals 4 minus 6xy. Bring your y squared plus x squared to the other side.
Yep.
So 3 dy by dx, 4 minus 6xy over y squared plus x squared. And then divide by 3. So dy by dx equals 4 minus 6xy over 3y squared plus 3x squared.
Yes. Might as well expand it like that. I mean, you could factorize top and bottom, but if you're going to factorize the bottom, why not factorize the top? It's not an urgent need for factorizing. That's fine. What was that? That was that. Oh, bugger. Right. So 3y squared.
Do you want to skip? Should we go to like G?
Yeah, you think we can skip? Fine. Sure.
Well, do you think we should skip?
Well, you never can. That's all the only point I'm making. Yeah. All of these are going to be different. Okay, maybe not that one. All right. Or that one in any really important ways. But I'm just guessing that F, for example, is going to give us great pause.
Should we do F then?
Yeah. I mean, you know, you still need practice on D and E, but or E. Okay, we're only skipping one. Right. Oh, bugger. How's that happening? Oh no. Damn. Oh, there he is. Oh, God. I
You all right?
don't know. Surely this will work. Right. So,
So you could rewrite that x equals 2y times x squared minus y to the minus 1.
yeah, okay, good. Good idea. All right then. So x equals 2y times x squared minus y to the power of minus 1.
Mhm.
Now what?
Now we could say um, so we'd set it equal to 0, wouldn't we? So we'd take this x over to the other side.
You've lost me. Why do you want to set it equal to 0?
I just thought that was what you were meant to do because all the other ones were set to 0.
Were they?
By the time we differentiated, they all just had a number on one side.
Yeah, that doesn't matter. They didn't all, did they? Have they all been like that, with a constant on one side? Apart from E, you see, the one we missed out.
Oh yeah.
No, that's not part of the deal. It's not like one side has to be 0.
So could
But
we
if
just
one
say?
side is a constant, it will differentiate to 0. That's just,
So we just say 1 equals.
yes.
So 1 equals
Good.
minus 2y
Why minus?
because it's minus 1 times 2y.
Why is it minus 1? I don't get.
Oh, no, ignore that. I was thinking about it wrong. So we do 2
To what?
2 times minus.
Not yet, no. What's the derivative of 2y with respect to x?
2 dy with dy dx.
2 dy dx. Yeah. So you've got to be aware of that you're differentiating with respect to something further inside the y.
Yeah.
Y is not the end of the story there.
Oh, okay. All right.
If it was, it would just be 2. If y were the variable of differentiation.
Yeah.
But this is a case of the chain rule. So 2 dy dx times what?
Times minus x squared plus
No,
minus 1.
why minus?
Because there's a minus to have minus 1.
Yeah, but this is a product rule, isn't it?
Yeah, so,
Leave this one alone.
I don't know what, yeah, I didn't mean, yeah, that should just be left alone.
Yeah. So it's basically that, isn't it?
Plus 2y times
And now it's
minus,
pretty, bear in mind it's a composite.
yeah, so times minus x squared minus y
Yeah.
times 2x. times dy by dx times minus dy dx.
Ooh. Then let's forget about the y detail. But what's the derivative of minus anything to the power of -1?
To the -2.
To the -2. Did you say that? Sorry, I might not have been.
No, I didn't. I don't think I did say it. I did write it down, but I don't think I did say it out loud.
Minus blob to the -2 times the derivative of the inner function, which is what now?
Which is 2x times minus dy, so minus dy dx 2x.
I think you're multiplying inappropriately. What's the derivative of x squared minus y implicitly?
2x minus
2x.
Oh, so it's just 2x minus dy dx.
Yes. Good. So there will be a lot to clear up.
Okay.
1 equals. Let's start maybe simplifying.
Yeah. How about we say 1 equals 2 dy dx over x squared minus y.
Yeah.
Plus we could say, well, it would actually be a minus instead of a plus there. Minus.
Well, I would rather keep it as a plus if we're going to have another fraction here with a. Otherwise, I think we're going to get sign trouble.
Okay. Plus.
Well, maybe not. No, okay, maybe let's. I shouldn't say that. I don't know which is best. Let's see what happens.
Okay. Well.
Minus what?
Minus 4xy minus 2y dy dx over x squared minus y.
Oh, yeah, I think you got it right. Sorry, can you start again? This whole fraction?
Yeah, so
I was confused. Do it again.
Minus 4xy minus 2y dy over dx over x squared minus y all squared.
Well, check what I'm writing. If you're looking, so on the bottom we've just got x squared minus y all squared, right?
Yeah.
So, well, yeah, I agree with all of that. So I take back what I said. So we're minusing, and then just take all this as it comes, which is 4xy.
Yeah, I don't know. Probably I'd try and make the denominators the same.
So you've taken that minus and put it there. That's fine.
Would you not do that?
Yes, no, we do need to do that now.
And of course, multiply the left top and bottom by x.
Yeah. Which, by the way, is what the quotient rule does. Provides a common denominator automatically.
Yeah.
When you've got what was essentially a quotient, we turned it into a product. All right. No, but that's good. I'm still just checking this from making sure. 2y. Yeah, that's all good. And now the common denominator. Go ahead. 1 equals.
So 1 equals 2x squared dy dx minus 2y dy dx.
You can't, unless you're going to expand that square very carefully, then no. I think you're going to have to leave it as. Oh no, sorry. Sorry, you're only multiplying by that. My bad. Okay, tell me what you said again.
2x squared dy dx minus 2y dy dx minus 4xy minus
Lovely.
2y
Yeah.
dx all over
Why do I do that?
x squared minus y.
Now, here's the sign glitch, probably. So I've written that for this fraction.
Yeah.
Carry on. Tell me what to write.
Minus 4xy minus 2y dy dx.
Do you see that, don't forget there's brackets around all of the fraction.
Plus, yeah. Plus.
So it's plus. All over?
Yeah, all over x squared minus y all squared.
All squared. Good. Okay, what next?
I'd factorize the top.
Yes, good. Okay, but shall we also do what with the bottom? I mean, the payoff from turning two fractions into one now really is we can get rid of the bottom, can't we?
Yeah. Yes.
By taking it away where?
By multiplying it, just bring it over to the other side.
Yeah, good. And then on the right hand side, were you going to factorize straight away? That would be great.
Isn't it? Wait, how come shouldn't there be brackets? You see what the x squared minus y squared.
Yeah. Otherwise, it's not the same, is it? Thank you.
Equals.
Yep.
2 dy dx.
Ooh, we haven't got 2 here, so let's just bring dy dx out.
Oh. Yeah, we've actually got one without dy dx as well.
2 or 3 times today, you've taken the initiative of when I've said let's factorize, you've taken more than one dy dx out. And it was good. And I saw that it was good, but I never do that. That doesn't mean it's wrong. I don't know.
How could you take dy dx out though, because you've got a 4xy there?
Yes, that's not going to be inside. That'll be an afterthought afterwards, after closing the bracket.
Hold on, shouldn't you have minus 2y dy dx up there? Up
A minus here instead of a plus?
No, the y dy dx should be a minus 2, shouldn't it?
Yes. Again, bloody hell, you're on a roll, aren't you? Keep it up. I'm not. Hell.
And then x squared. So then you could take 2 dy dx out. That's what I was
Yes, quite. All right then. I still don't want to, but yeah, all right, you could.
Then x squared minus 2y.
Well, x squared minus
plus 2y.
Well, hang on, you've taken 2 out though.
Oh yeah. I meant minus y.
Yeah.
Plus y.
Oh yes. Actually, we could just have cancelled those, couldn't we? I didn't notice. Well, of course I didn't notice because I didn't have a 2 there.
Yeah.
So
4xy.
So those cancel. And then minus 4xy.
All over.
Good.
X squared minus y squared.
So what next?
Oh no, what am I doing? It's not over that. Okay. Minus 4xy. Okay. Okay, so we're just left with, so that would equal, I'm just going to write it out clean because it's kind of hard to see, 2
Okay.
x squared dy dx minus 4xy x squared minus y squared, and then
Oh, I see your point.
say x squared minus y squared plus 4xy
Oh,
equals 2x squared dy dx, and then you just divide all that by 2x squared.
divide all what?
All the left hand side by 2x
What have
squared.
you got on the left-hand side then?
X squared minus y all squared plus 4xy
Oh, good.
all over 2x squared.
Yeah.
Yeah.
And then finally, dy dx equals?
X squared minus y all squared plus 4xy all over 2x squared.
Good. Well, I'm getting myself cramped there rather than giving myself more room. Lovely. Does it cancel at all?
Not that I can tell.
Me neither. Good.
Okay, good.
Let's do that again a different way.
Okay.
So let's so what would be a different rewriting than the one you suggested? It's no better. What you did was fine. But on the other hand, it was more difficult than necessary. It was good that it was difficult. We had to do the product rule with chain rule embedded, therefore a quotient rule kind of. We could, a different way to do it would be to apply the quotient rule, of course. But what would be a rewriting of this that's fairly straightforward? And then I don't know. I think we ought to get the same.
I'm not sure. Would the first step not be the same?
Well, no. Think of a different first step than you rewrote the right-hand side as 2y times that to the power of -1, didn't you?
Yeah.
Let's start by doing what we did here. Take the denominator over to the left.
Okay, so well, 0 equals 2y. Oh, okay, I see what you mean. So x times x squared minus y.
Yeah.
Equals 2y.
Good. Now we could save ourselves effort here with the product rule. We're going to need the product rule here on the left, unless we do what?
Multiply out.
Yeah, might as well. We know that's going to be a simpler differentiation, don't we?
Yeah, so x cubed.
So what do we get? X cubed. Then what?
Minus xy.
Minus xy equals
2y.
What now?
Take the 2y to the other side.
No, No,
Just
this is ready for implicit differentiation. If you start rearranging here, then you're probably trying to make y the subject, which you probably could. I'm
Yeah.
not denying you could. And that's what, we did the first one that way just for comparison.
Yeah.
But this is about finding an expression in terms of x and y. In which case, as soon as you've got something that's convenient for differentiating term by term, go ahead and do it. There's never any reason to hesitate.
Okay, so 2x squared.
Really?
3x squared.
Yeah.
Minus dy by dx.
Are you saying minus dy dx? Or what? What are we subtracting as the derivative of xy?
I thought it would just be minus dy by dx.
Well, then you're failing to see it as a product, which you do need to. It's not just a constant times y. It's
Yeah.
x times y, so you have got a product here.
Okay. So minus y.
Yes, that's right, because the x is differentiating to 1.
Yeah.
So just y. Good.
Minus x dx.
Good.
X dy by dx.
I would, with a product rule here, I would nearly always want, in my diagrams anyway, I want to put a plus sign there. So what I'll do is put a bracket.
Yeah.
So I agree it's minusing, but it's so almost wrong to think of the product rule as having a minus there. So I think we might as well put that. And then what, sorry?
X dy by dx.
Yeah, well done. You've totally got it.
Yeah, you got to keep an eye out for ones like that.
Yeah, oh yeah, I forgot to close the bracket.
Equals 2y.
Not quite.
Oh no. Equals equals 2.
Not quite. If it was 2x, it would be 2 down here.
Oh, 2y. Isn't it? 2 dy dx.
Yeah. Are you clear on that?
Yeah.
Difference. If it's with respect to x, then that's further inside an inner function, which is implicit. On the other hand, that's what, there have been occasions when we've had this discussion about the fact that 2y or any multiple of y differentiates to the same multiple of the derivative. But now we're seeing, in the context of implicit differentiation, we're seeing why that is, because y is an inner function.
Yeah.
So we're differentiating with respect to the whole of the inner function, which is 2, and then differentiating the inner function, which is dy dx, yeah?
Yeah.
What next?
Then I'd say 3x squared minus y equals 2 dy dx minus plus, x.
Oh, right, sorry, 3x squared minus what?
3x squared minus y equals 2 dy dx plus x dy dx.
Yes, it is plus, well done. And it might be clearer to you because you've not used brackets there and you've got a minus sign there, well done. Anyway, however it's looking to you, that's good. 3x squared minus y is that many dy dx followed by minus that many dy dx. Next.
You can say dy dx equals 3x squared minus y over 2 plus x.
Right, you see, and you're getting acceptably cocky now, aren't you?
I did actually do the other step.
Oh, right. Good. Okay, fine. But that's, you know, with practice, that's what you do. You say, oh, I
Yeah.
can see what's happening here. I'm taking dy dx out, and then I'm dividing by 2 minus x.
Oh no, we've got different ones.
Oh,
Because
have you not got this then?
no, I've got 2 plus x because I think, you know, when you said, so you were like keeping the brackets to try and make it a plus, it would actually be a minus, wouldn't it? Because you're minusing it, minusing that x. So wait, let me think.
Yes.
When I brought that x over to the side, it was a plus.
Yes. I know. I went over that in my mind.
So you've got to plus it because you're
Why?
minus.
Well, I need a plus there, don't I? Yeah, quite right. Yeah. 3x squared minus y minus the x is going to become plus on the other side. Of course it is. Good, good, good. There we are. Oh, is that the same as what we had before? We're wondering. It looks a lot simpler than what we had before, but my guess is it's probably the same thing. I don't know.
Well, that was probably the way I was meant to do it.
We ought to try, well, yeah, but we ought to try expanding this and seeing what we get. In case, but then we'll have a y squared over x squared that we can't get rid of. Oh, I wonder if we've got an error up here. But then if we have, I'll find it before I send you the thing, so it's not worth agonizing over a mistake I've made.
Yeah.
X to the 4 minus 2 x squared y plus y squared plus 4xy over 2x squared. That's not the same as what we've got down there, is it? Bugger. Or let's do it another way. By the way, in order to see, you know, confirm either one of those, because we've got a possible error there. Honestly, this is good algebra. And you're awake today, as we found. I mean, you know, possibly more awake, which is great. Let's try and make y the subject here. Practice our algebra. Okay.
Yeah. Of which one?
Make y the subject. In other words, refuse to do it implicitly.
What, we can do it again?
Yeah. But differently. I mean, it's like, you know, you don't want to do it again. I mean, you don't have to.
That's fine, we can do it again.
I mean, but we're turning it into a different problem, you see.
Okay.
Just like we did just now, but we can do that again. Do it differently. Okay. So let's try and make y the subject.
Probably do the same first step.
Yes, good. So x squared cubed, I mean,
Equals 2y. Then
x cubed minus what?
x cubed minus xy equals 2y.
Good. Next.
Then I would say
What are we trying to do? What's our medium-term target here?
Get y on its own.
Yes,
So divided by y.
I don't think that's an option yet, is it? Not a productive
Yeah, no.
thing yet.
Well, you could factorize the left-hand side.
Yeah, you could. Not in a useful way. If you're trying to make X the subject, yeah, maybe. Although, maybe not. Could you make X the subject?
Should we try?
I can't see a way of making X the subject.
Can you see a way of making y the subject?
Yes. I mean, what's been your good strategy all day to get dy dx on the right-hand side when you were trying to make dy dx the subject? If we're trying to make y the subject, let's get them on the same side, the y terms.
Okay, so x cubed equals 2y minus plus xy.
Yes.
Then factorize it.
Yes.
Equals y 2 plus x, and then
Yes.
x cubed over 2 plus x equals y. Yeah. All right.
Okay. So notice we've got an explicit function of x now. Let's do explicit differentiation.
Okay. So x cubed times 2 plus x minus 1.
Yeah, sure.
And then we can say,
sorry, time is too bad. What?
we could say 3x squared times 2 plus x to the minus 1.
Are you thinking of it like this as a product?
Yeah, yeah.
Good.
Plus
So dy dx equals?
dy dx equals 3x squared times 2x.
Yeah.
2 plus 1, 2 plus x to the minus 1.
Now, shall we, bearing in mind, if we notice that it's a quotient, so we're doing the quotient rule in the intelligent way, which is, well, an intelligent way, which is as a product rule.
Yeah.
Shall we provide what we know that the quotient rule provides, which is a common denominator? Instead of writing just 1 over 2 plus x, shall we write what instead? Because we know we've got an inkling of what's coming.
Oh, so 3, I don't know. 3x
What's coming
squared.
is we're going to want a common denominator of 2 plus x to 1 higher power 2 in this case. So we can write 2 plus x instead, can't we?
Yeah. Okay.
Plus?
So then you'd get 6x squared plus.
Sorry, where are you getting 6 from?
3.
Oh, I see, you've done this. Sorry, can you just tell me what to write here so I know that you've done this properly?
X cubed.
Yes, good.
Times minus 2x plus x to the minus 2.
Yeah, so it's minus 1 over the square, really, isn't it?
Yeah.
Power of minus 2, that's what that means.
Yeah.
And then don't forget the inner function.
There is no inner function.
Well, there is, but its derivative is
1.
so there isn't. I mean, I take your point. Okay. So the
Yeah.
derivative of that is just minus 1 over, oh, and I shouldn't have a minus there, did I? I was yapping. But half of the course today. Right, okay, so good. And now we've got a common denominator, notice. And then you
Yeah.
were starting to tell me more. Yeah, do tell me more.
So
one big fraction with what on top?
We can have
Now I see your 6x squared. Yeah, carry on.
we can have 2x squared, then in brackets x plus 6 over 2 plus x squared.
Sorry, how are you expanding? Which I hope you are. We've got this on the bottom, haven't we?
Yeah.
And how are you?
Yeah, so I got 6x squared
Oh, good.
plus 3x cubed minus x cubed, which then gives you 2x squared times x plus 6 over plus x squared.
Yeah, now I get you. You were on the next line. Fine. 3x
X,
plus 2, did you say? No, plus. What's going on? Plus.
it's 2x squared plus times x plus 6. It's 3x.
2x squared times 3 plus x plus 2x squared. Is that right? No, 2x.
No, it's 2x squared times x plus 6. Because you've only got 2x cubed on the top. Oh no, not 6, plus 3, x plus 3. 2x squared times x plus 3.
Yes, that's good.
Yeah.
Which is annoying because it's so close to being simplifying greatly straight away. But let's see if we can reconcile that with this one, which we can now that we've got an expression for y, haven't we?
Yeah.
So we could say, going back to the previous result, we could put that expression for y in there. Shall we try that? Let's try putting that expression for y into there.
So 3x squared minus x cubed over 2 plus x all over 2 plus x.
Right, let's try simplifying that. How would you simplify that?
Well, you could say I'd probably split it into 2.
That's
I mean, and then
not a bad idea to have.
So I mean, you've got 3x squared over 2 plus x,
Yeah,
and then
all right.
minus x cubed over 2 plus x squared, and then you could square
And in
the
fact, you probably recognise that as exactly where we were.
Yeah.
That was x cubed over the square. Although we avoided actually having that stage by providing a common denominator straight away. But it is basically what we would have had if we hadn't provided the common denominator, isn't it? 3x squared minus x cubed on top. Or rather 3x squared over one of them, power 1 on the bottom, minus x cubed over the square. So that is the same. So this one does agree with that, at least. Now, what about this previous monstrosity? Well, yes, when we substitute for y here, we might find that we get exactly the same. In which case, we're laughing. Ooh, x to the 4 doesn't look promising, does it? Okay, but we've got x to the 4, but it might cancel with one of these here. Jesus. X to the 4 minus 2x squared times y. And what's y again? Do you recall? In terms of x?
I don't remember.
This one here, x cubed over 2 plus x.
Okay. X cubed over 2.
X cubed over 2 plus x plus the square of that. Oh, this is just ridiculous. Over the square of x cubed over 2 plus x, or x cubed over the square. Just over 2 plus x. No need to go mad here, sorry. X cubed over 2 plus x, but we're having the square of all that, plus 4x times x cubed over 2 plus x, all over 2x squared. Okay, I'll check that and let you know if it works out. So I'll send you this with, and then you can see if it hasn't worked out, you can try and find the bug in this first attempt, which we did, you know, unnecessarily, you know, it was unnecessarily roundabout when we could have just lifted the x squared minus y onto the left-hand side.
Yeah.
But it's worth doing, you see. I just wonder whether we did it correctly and it's going to be exactly the same as the other two versions. So do you get what implicit differentiation is now?
Yeah, no, I do get it now. Yeah, that's helpful.
And it's fun in a way, just knowing that you don't need to know what y is.
Yeah, it's just doing it bit by bit, isn't it? Individual.
Yeah.
Yeah.
You may find out later what y is.
Yeah.
Okay.
Right,
by the way, let me know anytime if you have the opportunity to look at any of the past papers, you know, including the AS ones. You know, give yourself a boost. Your algebra is very good. You know, you've had to correct me on many occasions today, and
it's getting better. It's just from doing all this. I think a lot of this is helping. This sort of differentiation and stuff.
Good. But best of all is practicing past papers.
Okay.
That is the most effective. And then if you do that and you get stuck, you can always drop me an email for a hint.
Okay.
But also you can send me your work to Mark, or just ones that you couldn't do. Any of that, feel free. You know, it's in general that kind of thing is included in the cost. Okay, so don't hesitate to do that.
Will do.
All right, cheers.
All right, see you later.
Cheers, ta-ra.